We welcome you to the expert video PinPoint Sender LEDs. Today we are talking about the use and benefit of PinPoint Sender LEDs and photoelectric sensors from SiC. The technical advantages are obvious at first. True to the slogan, a lot helps a lot, through-beam and retroreflective photoelectric sensors can achieve longer sensing ranges. And photoelectric diffuse proximity sensors can detect darker or shiny objects better the stronger the intensity of the sender LED is. For through-beam and retroreflective sensors, the relationship between range and power of the sender LED is rather simple and easy to understand. For diffuse photoelectric proximity sensors, however, it is more complex and challenging. Our PinPoint LEDs not only emit expressively more light energy than standard sender LEDs, but they also have a specific sharply defined light beam characteristics. What is so important for diffuse photoelectric sensors? Diffuse photoelectric sensors evaluate the reflection of the light from the object or background. The light spot on the object or on the background is projected from the receiver lens onto the receiver. So a precise and unambiguous projection of the light spot on the receiver depends on the quality of the light spot itself. Without halo light, and the sharper and more homogeneous the light spot is, the better is the performance of a diffuse sensor. First, let's look at a classic standard sender LED and its light beam properties.
In a standard sender LED, the current to generate the light is distributed via a bond wire in the middle of the LED surface. The current flows from the contact point to the back of the LED and generates the light and the transition from the PNP area, which is green on the animation, to the NPN area, which is light red on the animation. In the area of the contact point, there's a high current density generating a high light intensity. Further away from the point of contact is a smaller current with a low sender light intensity. The light radiates in all directions, is annuated by the silicon or exits at the sides. This light emission results in a light spot and light beam that has gradations in light intensity, halo light, and a blind spot in the middle of the light spot.
These properties, essentially the size of the light spot include halo light, have a negative influence of the precision of a diffuse background suppression, both in terms of the minimum distance of object to background and in terms of the influence of reflective and retroreflective backgrounds. The best examples are safety rests, which can still cause faulty switching in the background from many photoelectric sensors a few meters away. Furthermore, it is obvious that a fine light beam geometry with a homogeneous light intensity in the light spot and a sharp demarcation without halo light is the solution. And this is where the PinPoint LED comes into play, which ensures a correspondingly precise and sharply defined light beam characteristic. With innovative production and functionality, our in-house developed PinPoint LEDs can provide this.
A PinPoint LED is completely different. The PinPoint LED is fully metallized. The point at which the current is injected is not at the center of the emission area, it is at the edge of the PinPoint LED. Due to the metallization and high and constant current can be injected into the LED. Light emission is precisely controlled by opening the metal layer only at the desired emission area using an etching process. Here you see the top view and the opening on the metal layer of the PinPoint LED from above. Based on this technology, a PinPoint LED emits strong, intensive light. The result is a sharp, high-intensity light spot with minimal halo, ideal for long-range detection and precise object recognition, even under challenging conditions.
In the meantime, we are now using the fourth generation of PinPoint LEDs, which offers even more robustness and range with up to 50% more light energy than previous generation and provides another new advantage. As already mentioned, larger light beam geometries with halo light and intensity gradients have disadvantages. The goal would therefore to keep a light spot as small and fine as possible. Certainly, this is the right approach. However, very small light spots have disadvantages.
If you take a closer look at the explanation already seen, you can see that only the expansion of the light spot in the orientation of the transmitting to the receiving lens causes negative effects. The expansion of the light spot against this orientation has no influence on the quality of object detection and background suppression. So it's obvious to reduce the light spot dimension in one direction and to expand it in the other direction, right? That's what we did. The first transmitting LED with a rectangular light spot is called PinPoint Pro and will first be integrated into the W12, W4 and W16 series. Because of new state-of-the-art technologies, the PinPoint Pro has up to 50% more light energy than the former PinPoint LED.
We hope that we have explained the topic of pinpoint in an understandable way. The advantage of pinpoint LEDs for object recognition are not the only ones we have in our quiver. Combined with our proprietary high-sensitive ASICs and smart algorithm, we can increase robustness, range and precision even further. Watch other expert videos on our homepage and on the web to learn more about.